Have you ever looked at your dying phone battery or a massive power bill and just wished we had a smarter way to hold on to energy? Well, today, we're looking at something truly fascinating that tackles exactly that. Welcome to The Explainer. We are going to explore a theoretical, highly advanced engineering concept designed to totally push the boundaries of how machines manage and preserve power. It's called the Regenerative Magnetic Kinetic System concept, and it is a brilliant exploration into self-sustaining looping systems.
Think about that for a second. What if future machines could recycle part of their own motion energy? You might be familiar with regenerative braking in an electric car, right? Where stopping actually helps charge the battery. But what if synchronized magnetic pulse systems, gravity-assisted recovery, rotational momentum storage, and regenerative electricity generation could all operate together inside one highly intelligent kinetic platform? Instead of just burning through power, what if a machine could catch and reuse the kinetic energy it creates while it operates? That's the exact promise of the concept we're unpacking today.
Okay, let's dive into this. Here is our roadmap. We'll start with 1, recycling motion energy, then break down 2, core system components. After that, we'll look at 3, staged pulse and upward motion, followed by 4, gravity and momentum regeneration. Then we'll run through 5, theoretical energy calculations, and finish with 6, a reality check and future vision.
All right, Section 1, recycling motion energy, the kinetic platform.
So, the overarching goal of the regenerative magnetic kinetic system is to act as an intelligent kinetic platform. Traditional machines use a constant stream of energy to do work, and honestly, a lot of that energy is immediately wasted as heat or friction. This concept proposes a radically different approach. It brings together distinct physical forces, magnetic pulses to initiate movement, gravity to pull weight downward, and a spinning flywheel to store the resulting momentum. It's kind of like a gymnast on a high bar, perfectly timing their swings to use gravity and their own momentum to keep going with minimal effort. By combining these forces in a synchronized dance, the system attempts to recycle its own mechanical energy instead of just losing it.
Moving right along to Section 2, core system components. Basically, building the machine.
And the technical blueprint for this concept brilliantly illustrates its anatomy. Looking at the transparent cutaway, you can really see the sheer complexity of the design. We've got a central piston mechanism on the left, connected via precision linkage joints to a counterweight on the right, and both are tied to a lower crankshaft and flywheel system. I know, it looks complicated, but we're going to break it down piece by piece.
So, the absolute heart of the machine is the Neodymium magnet piston, or NMP. This central piston moves vertically up and down through precision, low-friction ceramic guide rails. But what makes this so incredibly special is that word neodymium. This piston intrinsically contains a powerful, permanent magnetic field. It doesn't need to be plugged into a wall to generate a magnetic field. The physical magnet itself provides a massive foundational force. It's literally like having a built-in heavy lifter that never gets tired and never needs to recharge.
Surrounding that permanent magnet piston are multiple staged air core switching coils. Now, instead of using one giant, continuously active electromagnet that just drains massive amounts of power, this machine uses sequential coils that activate one by one right as the piston approaches them. It's like walking down a hallway in a smart home. Instead of leaving the lights on in the whole house, you're only turning on the light in the exact spot you're standing. Brilliant, right? We also have a flywheel and crankshaft at the base to store rotational momentum, an NMW counterweight to harness gravity, and Hall effect sensors. These sensors are super smart. They continuously monitor the piston's position, ensuring those magnetic coils only fire precisely when needed. And finally, main and auxiliary generators are there to capture the mechanical motion and turn it back into usable electricity.
Let's look at Section 3, staged pulse and upward motion, initiating the cycle.
Let's see how all this builds sequentially into actual motion. The cycle starts when those staged air core pulse coils activate sequentially. Remember, the permanent magnet piston already has a strong field, so these coils just provide a controlled, brief magnetic assistance to push it upward. As the piston rises, the connecting rod transfers this movement right to the crankshaft below, causing the flywheel to accelerate and store kinetic energy. Simultaneously, the counterweight gets lifted into the air. Then we hit a critical moment, top dead center. When the piston reaches its absolute highest point, a mechanical auto-unlock clamp automatically disengages, releasing the counterweight to fall downward.
Which brings us to Section 4, gravity and momentum regeneration, harnessing that momentum.
The instant that clamp releases, gravity completely takes over. The NMW counterweight descends forcefully, immediately transferring heavy rotational energy into the crankshaft and flywheel. And here,
Right here is where the true brilliance of the system shines. At this exact moment, the staged air core switching system turns completely off, zero power. The machine continues operating mechanically, spinning the main generator to create electricity without consuming any electromagnetic pulse power whatsoever. Because the massive flywheel is now spinning at high velocity, it acts as an energy reservoir. The stored inertia from the flywheel physically pushes the piston back up again, even while the electrical coils are totally deactivated. This momentum-assisted lifting allows for multiple synchronized cycles during what's called pulse-free operation.
Section 5. Theoretical energy calculations. Calculating efficiency. Let's look at the actual numbers, because this is where it gets really exciting.
So during the active pulse phase, when those staged air core coils do need to fire to correct the synchronization and keep things moving, they require an input of approximately 120 watts of power.
But remember that pulse-free operation we just talked about? Because the coils switch completely off and only activate briefly for synchronization, they are only running for a tiny fraction of the total operational time. When you average that out, this intermittent switching strategy dramatically drops the average effective electrical input down to roughly 30 watts. Guys, that is literally less power than a standard old-school incandescent light bulb.
Now, compare that mere 30-watt average input to the theoretical output. By harnessing the gravitational fall, the piston return motion, and the massive flywheel momentum during those coasting cycles, the system may temporarily produce an estimated 200 to 230 watts of combined effective operational recovery. This creates an absolutely dramatic contrast, a super low average input requirement versus a remarkably high temporary recovery output.
Let's walk through the physics breakdown that gets us to those numbers. The downward recovery system relies on roughly 35 kilograms of mass from the counterweight and another 35 kilograms from the returning piston assembly. That gives us a total moving mass of about 70 kilograms. When that 70 kilograms falls a synchronized distance of about 12 feet, it generates approximately 2,500 joules of gravitational potential energy. Even after we account for estimated mechanical and electrical losses, you still have an impressive 1,878 joules of effective regenerative recovery available. If you release that energy over 10 seconds, it yields about 187 watts. To put that into perspective, add in another 20 to 40 watts generated just from the flywheel's momentum coasting, and you easily hit that 200 to 230 watt temporary recovery range. It is such an elegant use of free-falling weight.
Section 6. Reality check and future vision. Limits and possibilities.
Okay, we absolutely need to ground these exciting physics with a completely honest engineering disclaimer. The source material is very, very clear on this point. This is fundamentally not a perpetual motion machine. Actually, scratch any idea of infinite energy. This concept firmly and entirely obeys the laws of thermodynamics.
Why? Well, because of real-world physics, right? A system like this will always experience unavoidable losses. Just like driving a car with the windows down creates drag, this machine has mechanical friction on the guide rails, drag from the generator itself pulling energy away, heat generation, magnetic field decay, electrical resistance, and switching inefficiencies in the electronics, the whole shebang. These factors guarantee that the system will eventually slow down and require external energy. However, recognizing these limits doesn't diminish the brilliance of the design. It actually validates it as a credible, grounded exploration of advanced mechanical efficiency.
And that leaves us with a truly exciting vision of the future. The design proves that by using synchronized regenerative recovery, momentum storage, and intermittent pulse assistance, we can drastically reduce a machine's external power demand. So, I leave you with this. How will intelligent kinetic platforms and regenerative looping shape tomorrow's technology? When we stop wasting motion energy and start intelligently recycling it, the possibilities for sustainable engineering are virtually limitless. Thank you for joining me for this explainer. Keep learning and keep wondering what the future holds.